In previous videos, I've gotten my Zynq-7000 board up and running. I have PetaLinux running on it. I've recently gotten sound support working, and I'm using just a little hardware codec for the sound. It's a WM8960. So that is essentially my sound card to my system. And in this video, what I'm going to do is get the sound effects in Doom running in PetaLinux on my build. So it's really trying to take advantage of this sound hardware that I've now added to my solution, and using Doom just as a fun way to do that. Nothing very practical here other than just a learning experience and maybe a little entertainment value for myself. So first things first, I need source code, and that source code would be the code for the actual Doom. And in a previous video I had shared that I'm using this FB Doom, so it's a frame buffer based Doom that works with a specific way that I'm doing my HDMI output on my board. And with that, if I go back, there is the FB Doom itself, and I've previously been able to build that and run that okay. But now I'm coming in here and I'm adding in the content from this folder. It's a sound server. And so basically the architecture is that the main Doom program is going to pass over information to this other process to actually do the processing and the playing of the sound effects. So I have to now add that as another application or an app within my PetaLinux setup, so that I'll have the Doom itself, or FB Doom, and then it will leverage this program to actually do the playing of sound. Well, that means that over in my project, I'm just using Eclipse here, and I've connected to the meta user folder within my PetaLinux setup, and there's a recipes apps. In previous videos I've covered, I previously talked about Doom and FB tests and the flash LED and this the SPI dev test. For this video I've added in this sound server. So there's Doom, there's the bitbake file for that, there's all the files that go with it with the make file, and now I've added in sound server, same thing. It's got a bitbake file, it has a make file, and then all the other source code. Now to create that, probably the first step is, let me go open a new window, and I'm going to just go into my PetaLinux folder. Let's see, PetaLinux, and my specific, actually I want to go there, I'm going to go one level up. I'm going to do a source settings from PetaLinux so that I can run the PetaLinux stuff here. Now within this I can say I would like to do a PetaLinux, I'd like to do a create, and what I want to create is an application. So you say apps, I say new, I would call it SND server. This is what I've already done, just showing you how I would have created that. And I want to use a template that's a C template, and I want it to just automatically get it enabled in the configuration so that this will build and be part of my image. So I would run that, and that would create this folder structure. It would create a README, a starter bitbake file, the files folder, and a starter C application that I could work with. So I replaced that starter C with the code from this GitHub over here. So I basically pasted this in here. I did a couple of things. I did tweak the make file, so what you see here. Now that make file, any of this, actually all of this configuration, I have already posted out to my GitHub. So on GitHub it's just REHSD, and I have an FPGA project, and within that there's a PetaLinux audio, and then I posted this folder that is everything you're seeing in this specific video. It's the configuration project spec basically from as it sits right now. So I put that up there about 5 hours ago. So as I'm getting into this, if you're curious, you can go into the recipe apps, and you can jump into sound server, and you can see exactly how do I have my bitbake configured, how do I have my make file configured, did I change anything in the actual files, which I probably did a little bit of tweaking within this. Nothing major though, I don't think, as far as changes that I've made inside of this. Now the way that this sound server works, from what I can tell, I'll just jump in here and there's a main. So this is what's going to run when you run this sound server, and it just is a loop, and that loop is just waiting for you to submit commands. And so like a command might be a P and then some hex values, and those hex values you would specify things like what is the sound number you want to play, and you can specify other settings that go with that, like step, which has to do with pitch shift and playback rate. You can specify volume, you can specify separation, so stereo separation. So basically, I'm going to use that. This little process is going to run on my PetaLinux. I'm going to be able to send it commands to play and play, a specific sound effect number. So that's the goal here. Now, as I was going through this, I did find that it does expect to use a device, a DSP device. And so somewhere down, I did a previous search here, so I can just use this. There is an init sound in this file. This is a Linux C file in that sound server project. And in it, it's going to go out and use a device called dev DSP. Well, if I flip over to my actual board, again, this is HDMI output on my board that I'm capturing. So this is me on a different keyboard now, directly interacting with my my board. And maybe I'll do a log out and just come in clean as a PetaLinux user. Here's my password. I'll change into dev and I'll do a listing. When I got into this, I did not have this DSP here. That was not part of my configuration. So I had to track back what's necessary to get DSP. And what I tracked back is, well, it comes with something called OSS. And I don't know a lot about this, but I think it's an older sound support layer for Linux. And I had to get that loaded up. So I've got over here, I've got my app, I've got the code, I've got my bitbake, I've got the makefile, all that lets me build this fine. But to actually get it to run, the sound server to run on my hardware, I had to get OSS support. Well, that was actually pretty easy. So you can do a PetaLinux config, you can configure the kernel, and this will take a couple minutes to come up. But while this is running, I had to come in and add in OSS support. And the fastest way to do that is when you get in here, you can do a / in the kernel configuration, search for OSS, and you're looking for OSS emulation. So enable OSS emulation. And then the second thing is that you want to enable the OSS core. And if you enable the emulation, I think it sets the core on by default. I'll flip through I had added a couple other things that I don't think were necessary. There's an OSS PCM API, and there's some plugin stuff that I enabled for now. But I think if you just simply enable the OSS emulation, it'll turn on the core and you'll be fine. Now this is going with the assumption I already have my sound, the ALSA, working within my Linux, my PetaLinux. And I think that emulation is just going to take advantage of that functionality and simply emulate that it is supporting this OSS. Okay, so this is coming up. I'm going to hit / to do a search. OSS. I'm going to flip down a handful of screens. And so here I get into, there is a sound mixer for OSS. I don't have that on. Here's the emulation. This equals Y tells me that this is on. It will show up within this hierarchy. So you go into device driver, sound card support, which has to be on. ALSA, or Advanced Linux Sound Architecture, that has to be on. And then there is an enable OSS emulation. That is what I got turned on. And it will automatically then select OSS core, which is great. So I keep going down. I also chose this PCM. Like I said, I don't know if that one's necessary. Same with the plugins. I did not enable this sequencer, and there's the core that would have gotten turned on with the above. So got all of those turned on, and that was it for the kernel configuration. In rootfs configuration, there is another OSS library or lib. I did not turn that on, so I'm not using that. I don't think that's, obviously it is not needed for what I'm doing. And I'm not sure what additional things that would give you, but I did not change anything in the rootfs, I guess is the short version there. So with that, then I would have the necessary kernel support. I would have, this over here that will build as part of my PetaLinux build. And I could do something like come in here and just do a PetaLinux build. And so one option for me is then to do, let's say, PetaLinux-build. I would run this. That would take a little bit. I would then prepare the images for my SD card, copy things over to the SD card, put that into my system, boot up, and off I would go. For now, let's just assume I've done that for the sake of time. But if I go back now to my system, I can jump over to that keyboard, and I'm going to go to user bin. Maybe real quick, I will just double check I've got my audio settings okay. I've got my speakers off, but I have my headphones on. I'm running the headphones into my the headphone output of my Zynq-7000 board into a separate machine here that is going to capture audio here, so I can overlay the audio so you can actually hear. I won't hear it as I'm talking. It shouldn't get picked up on my microphone, but it will be something I can overlay in the video. So that all looks fine. Speakers off, headphone is at a decent level, and my overall scrolling to the right master volume control is at a reasonable level. Now, if I get out of that, then I just do an ls. I do I look for this, is the sound server there, and it is. I can go ahead and run it. And I had added some additional logging things here, this, init data, and init music complete, just so I know that was there. It's loading the WAD file, so it's loading this doom1.wad. Okay, that's great. And now I can basically submit commands to it. So it's just sitting here. It doesn't look like it's doing much, but I could come in and say, well, I want to play sound effect 1 with, certain values for, again, it was step, volume, and separation. And I'll do that one more time. So P010A0F1C. And when I run this, it should be a pistol sound. Now, if I want a different sound, let's just say, let's go see what is the 02. Should be a shotgun sound. So we'll run that again. 02, 0A, 0F1C, etc. And this is just going to basically run, and so that when Doom is running, it's going to be submitting stuff to this constantly of play this, play this, play that, and that's how the sound effects are going to work. So I'm going to break out of that, and coming back over here, it's coming into this sound serve, and it's going through this loop, it's processing this command, and then it's writing out data. Basically, this is what is the entry point to get all of that sound effect playing. And I didn't have to do a lot of other stuff in here. Back to this over here where I was searching for the dev DSP, this is under the init sound, so I can see that when it goes to initialize, it basically is coming in here and trying to open up that device, and I had to make sure that device was there. So I've got the device, the init sound works, I have this other sound serve, it has the main, it's just going to sit and listen for commands. I just need to make sure I get it a good command, and we're off and running. So this part is now taken care of. I've got sound server, and that is working. The next thing then is to actually get Doom to use that. So I'm going to close these and come up to Doom. And within Doom, there are some files that I want to pay attention to. One of them that I tracked down was iSoundC. And within iSoundC, I'll search for a couple things here. There's an init in this. And so here's this init sound that's inside of that. And when I go to initialize sound in Doom, it's basically building, it's looking for that sound server program or executable that'll be sitting in the same folder as my Doom. And I'm building a command that just says, okay, let's run that. And if it has any output, I don't want to see it. Just, send it over to dev null, so don't show it on the screen. And as I get that loaded, I guess, or that string built out, I then say, well, open up that. So open up sound server with these parameters here. I pause for 5 seconds and just let it fully load so that the main Doom program doesn't continue until the sound server is fully loaded. I probably only need 2 or 3 seconds here, but I put 5 just to be safe, and I've not tried to dial that down, and this is fine for now. There's maybe a more elegant way to do that, but this is working, so I'm not going to complain about it. Then in addition to this, there is a start sound, and in the start sound, this was all there in the source code. As far as this procedure, one of the parameters, the sound effects info, I can pull the name of the sound effect that's being requested to play, and I put in a little lookup routine that then goes out, and let's see, there's a sound file, sound C, that has this enum that lets me see that, okay, I've got sound 0 is no sound, and that looks like for whatever reason the developer had to have this 0 that had no sound in it. But then starting with the next one, which is index 1, would be a pistol, index 2, shotgun. So if I say play sound 1, that's the pistol, sound 2 is the shotgun, etc. And you can kind of see what all is in this list. So those are my sounds. I then say, well, get me the name, go over to that array, basically, find me the index of the sound that was requested to play, put together the little P command. So it's, P, and again, those hex values for the different pieces of that, which again was give me the sound number as a hex, 2-character value, give me the step, the volume, and the separation. So that ends up with a P, and then 4 additional characters after that that are hex values for those settings. And then just simply write that over to this sound server program that's currently running. So that's how I understand that's all working. Those are the tweaks I made. There was some other code in here. I've got some stuff commented out that seemed more complicated and maybe required me to have other sound card support or library support running on my system that I don't. And so I'm just going with this very simple approach right here. Just I know the sound name, convert it to its location or sound number, and then just call that other process sound server, passing it that number that I would like to actually have it play. So then with that, I can get all of this built, and that would give me a process or a program, Doom, that I can then run. So back over here, if I just do a listing of any Doom related stuff inside of my user bin, I've included an FB Doom, and then also a Doom 1 and a Doom 1B WAD. And I guess real quick, the difference between these WAD files, the first one, Doom 1, you can see is quite a bit larger. That has, I believe, all the music content in that version. The next one is the one that is like the shareware, the free version that doesn't have the music stuff in it at this point because of, I'm sure, licensing or something that goes with that. So I could then, or should be able to say, well, let's go ahead and maybe I'll flip this to full screen. And let me just flip over to my OBS and flip that over. So on the recording, I'm just capturing now that HDMI output on my dev board. But I can run FB Doom, and I have to tell it what the iWAD file is. And so let's go Doom 1 WAD. Now when I run this, again, during its initialization, it's going to go start up that sound server process. And right here is where it's doing that pause. So it started it, it's waiting for it to finish loading, and then off we go. And now I'm at the main menu of Doom, or at the intro splash, and now into the main menu. So now I can go through this, and I'm not hearing the sound effects right now because it's being piped over to a separate computer that's recording this audio. But I would expect that at this point you're hearing the sound effects of the demo track running. Let me hit new just to get rid of all that noise and just sit here nice and quiet for a minute. But now I can run around. I can do things like shooting, and I'll blow up this mural. So shot, and blow it up. And I should be able to run around and hear other sound effects as I go, whether I'm picking up things, blowing up things, opening doors, hearing bad guys. So okay, so that is, those sound effects working, and, it seems to be doing a pretty decent job. Now, something I have not done yet is add music support. That looks like is another level of complexity, and the source code doesn't have it in there as far as I can tell. It's kind of framed out of all the spots you need to go implement music support, but it is not there. So maybe I need to find a different source for some of this that might have that built out, or I can maybe work on trying to get music support working at some point. I'm not so worried about the background music. The sound effects was my first priority. So I'm going to flip my recording screen back over. Now, as I'm going through that, of course, I am not that great with C, and I, will make changes and want to test those changes. To have to do a full PetaLinux build over here, and then put that onto my SD card and swap SD cards and reboot my Zynq board. That's a lot of work to be doing this. Ideally, at some point, I would get to where I could interactively debug a process on the Linux side of things, and I'm going to look into that in the coming weeks to see what it takes to do that. I think, is it GDB or something like that maybe would support that. So I'll get into that later and figure out, can I, from Eclipse here, interactively debug this as it runs on my hardware? And I think the answer is yes. I just got to go through how to do that. But as I build things, as I change things and I want to test it, I don't want to go through the multi-minute process of building an SD card and flipping cards. So what I found is, if I go over to a certain folder, this is my PetaLinux folder, and when you do a build, that output goes into this build, temp, work, and in my case, this Cortex A9, whatever, and then into a Doom folder. So as I'm building the Doom program here, and then a 1.0. And if I do an ls in there, there's a whole bunch of files, but I wanted to show you, and maybe I won't do it for the sake of time, but if I do a normal build down here, like what I have in the command line, if I just say build this stuff doesn't stay there. You'll only see a few folders there, and you won't see all of this content. And I wonder, can I scroll up? I don't have a previous view that you can see of that, but you won't see all of this. But if you want to be able to build an app and have it leave this stuff, these are like temporary artifacts, you can say, I want to build just a single component that is Doom, and then you would add into this a little extra on the parameter side of things so that you can add in and say, I want to just build that, but I don't want you to delete the temporary artifacts. And what you do is you add a -x compile. And so now if I was to run this, it's going to build Doom, but it's going to leave these temporary artifacts here, which is really handy, because then one of those is this, let's see, ls is FB Doom. So there's my FB Doom right there. And I will do -L. That other build just completed. My clock, which I'm not recording at the top of the screen, says 2:51. And this here is showing an older time. Let me do an updated listing. Oh, probably because I had nothing that changed. It could be a very good reason for that. Maybe. Let's just see. I was just expecting, this says that it was built at 2:14. My clock is at 2:51 right now, and I'm curious, I want to test something here. So I might just do something that causes some type of change. So I make some type of change, and then I come in here and I do the compile of Doom with the -X compile. And I'll give it just a minute. It goes pretty quick for that. Okay, and I'm going to come back here now and do another listing. Okay, now that shows 252. So that change resulted in basically new files, but in this folder now, it has left the actual executable, and it's almost 2 meg in size. And the nice thing about my Zynq board is it's on the network, so I can just connect to it over the network, and I could do something as simple as just copy over this. What I've been doing from this folder is I just come in here and I do an SCP. So I want to securely copy, and I want to securely copy FB Doom. And then I'm going to copy it as user PetaLinux on my remote machine, which is the Zynq board. And I'll plug in my IP, and I'm going to just drop it in my home folder PetaLinux, since that user has access to that folder. And off we go. So now I can jump over to my PetaLinux output and change into my home folder. And I'll just do a listing and FB Doom, and there's the 254 timestamp, which is right now. So that is coming over just fine. So I can tell it did update that. But from here then, and maybe I'll just clear my screen to get rid of all this junk, I could copy FB Doom to my user bin folder. And I'll have to sudo that. But now if I go into my user bin, I can look and see that, let's just see, I'll look for Doom files in general, and I can see that updated FB Doom is there, and it looks like it's executable. So if I want, I could go back now and say, well, let's go run that. Let's see, in my list I had that, and off we go again. So trying to really, speed up the process that I can be in here, and I'm going to get out of this just so I don't need that running. Oops, I completely closed the capture window. Let me get that back. And I meant to escape out of that. Let me get out. But now I can come over, I can update the code here. So if I wanted to say, well, I don't need this declaration, I can save it. I can flip over to here. I can quickly just compile it. And then I can flip over here as soon as that's done and press this and get it copied over to my system. And what I've actually been doing is just running it from my home directory, not even the bin folder. And so I'm just looking at this background. I'll let this finish. And then as soon as that's done, I'll press enter on this top command, put in my Zynq board password. There we go. I can jump back over to this system. And what I've been doing, let me make this big for a second. I will change into my home, and again my FB Doom is there, but I just have copied from user bin. I need the sound server, and I'll put that in my current folder, and then I will also copy the Doom 1 WAD. So now I can just, right from this folder, run Doom. So I can constantly be over in this window transferring whatever was built in this window. So I'll build it here, transfer it, and then I can run over here and just run it. So I can just up arrow to my command that ran it like that, and off I go. And so that process is all really quick. You know, I can update my code. The build takes half a minute, if that, and then the rest of the copying takes another half minute. So I can very quickly be transferring this and testing. And then if I find some issue, I can jump back to my code, quickly tweak it, again, compile it, transfer it, and run it. So like I said, maybe next steps, I want to figure out how to do interactive debugging. That'll be a totally different topic and video. Maybe I can get Doom music working at some point. I got to see what all that's going to take. So far as I've gotten into it, just kind of dumping into the files here. It seems like there are expectations of another type of sound or multimedia support in PetaLinux that I don't have yet. And it could be that it's going to be not such a big deal to get in and work with it. Oh, let's just see what they have in here. So this whole timidity, I don't know what that is. Some of you are probably familiar with what that is. But it seems like there's this SDL, and that is something that I don't believe my system supports, or that I have installed. I don't believe it's part of PetaLinux. So I would have to bring it in as maybe a custom Yocto layer or something like that, if it's even possible. But that seemed like a deeper rabbit hole that I didn't want to go down right now. So let's just see. If I scan through my notes, I think I've covered everything I was hoping to cover. You know, again, I'm picking up from previous videos where I have PetaLinux with this hardware codec, or this sound card essentially running. I've gone out, I've grabbed FB Doom along with the sound server that is available for source code. I've created an app for the sound server. From that app, I then basically build it, include it with my Doom. Doom can now call it to play sound effects. I had to add into my PetaLinux image support for OSS so that I would have this DSP device show up that the code is looking for. And then basically it's just sending these little play commands over to that process to actually play. I updated the Doom code to properly initialize and connect to that process for the sound server, and format and send over the little strings of requesting which sound effect. And then I quickly show just how I'm doing the building and transferring instead of having to build full images constantly. And all that seems to be a pretty easy process for me to work through. And then everything again is posted out on my GitHub, so that if you do want to look at any of this in detail, you can. And it looks like I'm about a little over half an hour into this, and that's where I'm going to stop. So hopefully, as with these other videos, you found that interesting, whether you're coming from the Zynq or PetaLinux, or just Doom and audio on old devices or different devices. Hopefully you found this interesting. So drop comments if you have questions or feedback or suggestions. Thanks, everyone.